Welcome back. I think many of you are, most of you are back. Please, in the chat box, just write down something so that I know that you are here. I can access the chat box, I think, so you just write down something. I was present, or write some comment, then I will know that you are there. If you do not write it, I'll have to mark you as absent. So please write something in the sub box to let me know that you are here. Okay, we're not going to get on to the next problem now. The next problem is this thing here. In how many ways can the letters of the word SAMO be arranged if the vowels must always be in alphabetical order? Okay, now this is a counting problem. There's a lot of counting that is done in Olympiad problems, but the counting is also done at school mathematics. The reason why you need to count, you need to know how to count. Here we are not just speaking about counting from 1, 2, 3, 4. Yeah, you say you got some scenario and you want to know how many are there in that scenario. So you have to know some strategy in how to count them. I think that the last two lessons I've given you a certain principle, so you hopefully you understand that principle. So this is another problem involving counting. So what we can do is write down all the different ways in which you can write SAMO, but there is a constraint, and that is the vowels must always be in alphabetical order. In other words, the A must be before O. So you're not allowed to put O and A. So if you do this down, you will see I've actually done it here. Hopefully you can see this. So you write down all the ones which have A in the beginning, right? This is one of the ways of doing it. Do I have A in the beginning? And then the other three, S, M, and O, you arrange them anyhow you please. And you will see that there are 6 ways of doing that. Right? You can start with S, or you can start with M, or you can start with O. And each one of those cases corresponds to 2 endings, M-O, O-M, O-S, S-O, S-M, M-S. And like that, now you can start with A, or you can start with M, or you can start with S. You're not allowed to start with O. But if you start with M, remember you have to put A before O. So here you see that there are only 2 ways of doing that. And same thing with these. Actually, I should have had this M up here. Okay, sorry about that. 3 M's should be next to each other and the 3 S's next to each other. Anyway, this gives you the whole lot, and the answer is, as you can see, 12. You can count it like this. Now, this is a long and tedious way of doing it. The way to argue it out logically, it says, okay, I need to put A and O into 4 boxes. Then these are the boxes now. Each box has got four objects in it. So we put these 4 letters of the alphabet into 4 boxes, and we must make sure that the A is before the O. So you put A and O, you can put them anywhere, provided you must put A before the O. And to do that, you need to choose 2 boxes from 4, right? You need to choose 2 boxes from 4. And I told you the last time, whenever you want to choose 2 from N, it's a very important principle. It's N times N minus 1 over 2. If you went over those, the last PowerPoint, you would know what I'm talking about. So yeah, it's 4 times 3 divided by 2. That's the number of ways in which you can choose 2 boxes from 4. 4 times 3 divided by 2, and that gives you 6. So you can choose 2 boxes from 4 in 6 ways, and the moment you choose 2 boxes, like these 2 boxes, you can fill it with A and O. That's the only way you can fill it. A must come before O, right? Then once you choose these two boxes, then you have to fill these two now. But here you can put S and M. But you can put S first and M afterwards, or M first and S afterwards. So there are two ways in which you can fill the remaining two boxes. So for each of these 6 ways, like this one here, there are 2 ways in which you can fill the remaining 2 boxes. Right? So altogether you got 6 times 2, because for each of those 6 you got 2 ways of completing the story. It's 12. So you can logically argue this instead of writing this thing down, like this, and it takes a long time. If I had a bigger word, like if you had, instead of having a 4-letter word, if I had a 10-letter word, then it's almost impossible to do it like this. But this argument here will be able to help you to get to the answer much more quickly. Okay. So how are you guys? Are you happy with that counting problem? It's not a very complicated kind of problem. Show me by show of hands if you're happy with that. Reactions, right at the bottom of the screen. Yes, Robert and Tian. Okay, that's good. Nasayam, hey, Nasayam, you are here as well. The Frosts are quite happy. Edward. Okay, Ruway. All right. So let's get on to the next problem. The next problem now would be so it says here the problem 11, let y equal to mx plus b be the image when the line x plus 3y plus 80 is reflected in the x-axis. Determine the value of m plus b. This is a problem on graphs. So there is a kind of a geometrical picture about this, and there is a graph, and there's a line, there's a straight line.
Sorry,
Yes.
Prof.
Yes.
I think you cut out while you're doing problem 10. So can you?
Oh, I was cut out, huh? Okay, which one was
that?
Yeah. Sorry. Oh, I see.
I think you're explaining the boxes when you got.
Oh, okay. This one here. You want me to do
Prof.
all of it again?
Just the way you're explaining the boxes.
Okay. Now, we are looking at the number of ways in which you can arrange a 4-letter word, SAMO, right? So you are going to get different arrangements, as you can see here. And in each arrangement, you can think of these arrangements as 4 boxes to be filled with letters A, S, M, and O, right? So if I put this thing here, I need to know how many ways can I fill these boxes? The condition being that the A must come before the O, right? So the way to do this is that you take any one particular choice, like here I've chosen A to be here and the O to be the last one, and then say, in how many ways can I fill this box? And the answer is I can put S and M here, or I can put M and S in that order. All right, so let me just get my spotlight. Oh. Yeah, you can put S and M, or you can put M and S. So for this particular choice, you got 2 ways in which you can complete this box: A, S, M, O, A, M, S. So 2 ways in which you can complete this box. Now the question is now, how many ways can you choose 2 boxes? Really, you need to choose 2 boxes from 4. And the way to choose 2 boxes from 4, all right, now I gave you a method of finding the number of ways of choosing 2 objects from n objects. Number of ways of choosing 2 objects from n objects, and I made quite a big issue of that. And the answer was, it is n times n minus 1 divided by 2. All right, so here it's 4 times 3 divided by 2. So this is the number of ways in which you can choose 2 boxes from 4 boxes. So There are 6 ways in which you can put the A's and O. A and O here, A and O there, and so on. But each time you have such a choice, you have 2 ways in which you can complete the word. So you have 6 times 2 equals 12, and that's 12 ways altogether to create these 4-letter words. Are you all happy now? All right.
Yes, Prof. Thank you.
Okay, thanks, Shiva. Okay, and thanks for pointing this out. Okay, here now we are looking at graphs. The question is, let's just look at this question here again, because it's a little bit tricky. It says that you got a straight line, it's given, x plus 3y equals 80. Then they say that there's a new line here, which is the image when this given line is reflected in the x-axis. What do you mean by saying reflected in the x-axis? The meaning of that is the x-axis now becomes like a mirror, and this line here is looking, each point in that, on this line is looking into that mirror, and it is seeing, you want to see where the image is. It will be on the other side of the mirror, the image. All right, and that will be your reflected line. So let's just look at this picture here, and you will see. So this is the original line, x plus 3y equals 80. That's the equation of the line. Now, how do you draw that line? There is, one of the easiest ways of drawing a line is you make y equal to 0, for instance, and see what x is. All right, now, if you look at this point here, it's got 2 coordinates. The first coordinate is 0, right? And to find the second coordinate, it lies on this line here. Its first coordinate 0 because it lies on this line, right? But to find the second coordinate, it also lies on this line. So when the first coordinate is 0, x equals 0, if it lies on this line, it must satisfy this equation. So you put x equal to 0 and 3y plus 80 equals 0, and you will see that y is equal to negative 80 over 3. So that is how you calculate the y coordinate for this point. It's 0, the first coordinate is 0, and the second coordinate is negative 80 over 3. This might not have anything to do with the problem in question, but I'm using this opportunity to talk a little bit about graphs. And then if you know it's a straight line, you need to know only one other line. So the other line, you see where it cuts the x-axis. Now this point here, the thing about this point here is that it lies on the x-axis, so its y coordinate is 0, but it also lies on this line. So you can make the y coordinate 0 in that equation. If you make y equal to 0 here, then you can solve for x, and you're going to get x is negative 80. So the x coordinate here is actually negative 80, while the y coordinate here is negative 26 and 2/3. It's drawn badly. It's not drawn to scale. This line looks bigger than that, so it's not supposed to be. Anyway, so this is your straight line. You join these 2 points and you got a straight line, and that is the straight line they are speaking about. This is a straight line whose equation is given by this, and if you can write it like this because you are familiar with y equals mx plus c. So if you write it like this, then this becomes your y-intercept, which we saw, and this gradient is negative 1/3. You can see the gradient is negative because it's going from this second to the fourth, and the actual rise and the fall will be 1 over 3. 1 rise and 3 fall. So it's not as steep as this. Anyway, so this is the original line. Now this line is reflected across the x-axis. So this point here, for instance, it remains exactly as it is, because when you reflect it, it doesn't move. But now you take this point here, for instance, and you're looking at the x-axis of the mirror. So when I take this point, the mirror image will be this point here. See? And if you take this point here, for instance, on this original line, its mirror image is up there. So each point has got a mirror image. Now you can see, I've got a general thing here. I've got xy in the original line. Its mirror image will be x negative y. The x remains the same, but the y changes sign. That's the mirror image, right? You go the y downwards, it's now become y upwards. So it becomes x negative y. Right? The diagram is rather small, but the coordinates here are x negative y. So it means that the y in this equation must be replaced by negative y to get that equation. See, that is the crux of the matter. The y in this equation must be replaced by negative y to get that equation. So there's your original equation, x plus 3y plus 80 equals 0. The y has to be replaced by negative y. So then the new equation becomes x minus 3y plus 80 equals 0. That's what we got, right? And the question says, this new line is your reflected line now. It's a new equation. This is your reflected line. And they say if you write it as y equals mx plus b, that's what they've got here. Y equals mx plus b is the image of the reflected line. So we need to write that as in that form. You have to write this as y equals mx plus b. So you make y the subject, you get 3y equals x plus 80. If you take it to the other side, so therefore y is x plus 80 divided by 3. That's what you got here. Divide it by 3, the x is divided by 3, and the 80 is divided by 3. And you got y equals 1/3 x plus 80 over 3. And therefore, your m value in the problem is 1/3, and the b value is 80 over 3. And you need to calculate m plus b, which I didn't do. Okay, so I've been naughty here. I should have, I think the question was, if I'm not mistaken, to calculate m plus b. Yeah, m plus b. So I really should have added the 1/3 and the 80 over 3. So the answer is 1/3 plus 80 over 3, and the answer is 27. That is m plus b. If you got any questions, put it in the chat column, and Shibar will raise it with me. Okay, are you all okay? Okay, no questions. Let's go on then.
Looks like they're all good, Prof.
Yeah, good. Okay. Now that's a kind of tricky problem because it's a problem about reflection. So you do it like that all the time. When you, I'll tell you something else. You know, when you have, let me just go off at a tangent here, as I usually do. Annotate and draw. Do that. Oh, I can't do anything. Okay, I'll just do it here somewhere. You see, you can reflect across any line, and when you reflect across the x-axis, right, as we saw, the y becomes minus y. If you reflect across the y-axis, right, the y remains the same, the y coordinates remain the same, but the x will change sign, right? So there the x becomes minus x. It's nice to remember that. But an interesting one is where you reflect across what I call the diagonal, the line which goes through the origin but makes 45 degrees. It bisects this 90 degrees. This line here, a very important line, right? It goes through the origin, so the c value is 0, and the m value is 1 because it's 45 degrees, right? The slope is 1. So this is y equals x. Now when you reflect a point across y equals x, a nice thing happens. If I got, say, 2, 3, for example, if I reflect it across this line, the 2, 3 becomes 3, 2. You switch the roles of x and y, right? So now remember that when you're reflecting along the line y equals x, this happens very often. then your new point, it switches coordinates. It becomes 2, 3 becomes 3, 2. 5, 6 becomes 6, 5. The new point, the reflected point. See? So please remember that, because we will be using that fact at some time or the other. Okay. Now let's just get on with this thing here. We finished with this problem, and we are now going to get on to the next problem, which is why is this? Am I still in draw maybe? Mouse. Yeah. Okay. Now this problem here, you got two congruent rectangles. That means these two rectangles are exactly the same, with same length and same breadth. They are shown here. The area of the rectangle is 12. Okay, the area, you know the formula for the area, it's length times breadth, and its perimeter is 14. It means if you go traverse the entire boundary, you're going to get 14. So they tell you the circumference of the circle is n times pi. The question is, what is n? All right, before we go on to that, let's just see now. You obviously, you have to get an unknown. The problem is to solve for an unknown, and the unknown here in this problem is n. But your actual problem, you've got two unknowns here, because you've got the length of the rectangle, and you've got also the length of the rectangle, and you also got the breadth. So let's give a name to these, the length and the breadth. Actually, you have to give two names, x and y. Let's call this x and let's call that y, and see what happens. Right, then we know that the area is 12, so you got an equation, because length times breadth, which is xy, equals 12. Right, so you got one equation, and the perimeter gives you another equation, because you got x and you got y, and this is again x here, and again this is y. So if you take the perimeter right round, you'll have two x's and two y's, right? And you know the formula for the perimeter is 2 into length plus breadth. Actually, that is what you are getting, 2 into x plus y. Because you got x plus y gives you half the perimeter. So the entire perimeter will give you 2 into x plus y. So you got another equation, 2 times x plus y is 14, which says that x plus y is 7. Right, so that gives you two equations. I'm going to write it down here, show you what's going on. Oh, this fellow is still sticking around here, so let me just get rid of this guy. All right. X plus y equals 7, xy equals 12. Now, you got very small numbers here, 7 and 12. And so mentally you can say, what am I looking at? I'm looking for two numbers which when added gives you 7 and when multiplied gives you 12. And straight away you can see what it's going to be. You can have x equals 4 and y equals 3. Or you can even have x equals 3 and y equals 4. So there are two answers here, right? But the pair xy is 4 and 3. 4 plus 3, 4 times 3. So by inspection, you can see that. Okay. All right, so let's just put that down here. You got 4 here and you got 3 here. And now you want to find the circumference of the circle. To find the circumference of the circle, you need to have the diameter. The circumference of the circle is pi times its diameter. And the diameter is twice the radius. So I need to find the radius of the circle or the diameter, because it's better to find the diameter maybe, because then you can say circumference is pi times the diameter. But what is the diameter of the circle? Well, when you look at this, you see you've got 3 here and you've got 4 here. So this actually is a right angle. Just one moment. Oh yeah, There's a 90 degrees here, which I didn't see. Okay, so there's a 90 degrees here. Now, it's an important fact. The grade 10s might not be aware of this, but if you've got a circle and you've got a diameter, then the angle, the diameter, if you take any point on the circumference, no matter where you take the point, if you take a point here, like for instance here, take any point, like take a point here, and I'm going to join the ends of your diameter to that point. The nice thing is, if you've got a circle and you've got a diameter, this angle here will always be a right angle. Rather remarkable fact. Can you see? No matter where you choose a point, that angle will always be a right angle. And here, and even conversely, if this is a right angle here, then this must be the diameter. So this is what we are using here. You see this angle here, which we've got. This angle here is a right angle. So therefore, this must be the diameter. Okay? But Pythagoras, if this is 90 degrees, this is 3, this is 4, this has to be 5. 3 squared plus 4 squared is 9 plus 16, which is 25. So the diameter is 5. So this thing here is the hypotenuse of the triangle, but it's also the diameter because this angle is 90 degrees. Therefore, that must be diameter. Right? So the diameter is 5. And the circumference of a circle is pi times diameter. So it's pi times 5. So the circumference is 5 pi. That's what you got here. Right? And the question says the diameter, circumference is n pi. So here you got it's 5 pi. So n would have been equal to 5. Okay, so you got a new piece of information here, namely that a diameter, if you join the ends of a diameter to any point on a circumference, you're going to get a right angle. Are there any questions? All right, good.
No, I don't think so, Prof.
Okay, thanks, Rabah. Okay, we're now getting on to the next problem. Problem 13. For how many positive integers k does the equation kx minus 12 equals 3k have an integer solution for x? Now that's quite a mouthful. You have to try to understand what are they talking about here. So they want to know how many positive integers k does this equation have an integer solution for x. Now what I'm going to do is put some values for k and see whether the equation, and then solve. If I put a value for k, I can solve for x. So I'm going to do that and then see whether that x is an integer. If that x is an integer, then that k is acceptable, because you want to know for which positive integers k do you have an integer solution, right? So when I go down here, say I'm taking, if k equals 3, come on, tell me. I didn't write down the answer. You all can speak. K equals 3. What have we got? 3x minus 12 equals 9. Right. So then you get 3x equals 9 plus 12, which is 21. And 3x is 21, x is 7. X is an integer, which means that when I put k equal to 3, you do get an integer solution. So k equals 3 is one of those things which is acceptable. It's an acceptable solution. Hey, I'm getting pretty good at this. Right? Now let's try k equal to 5. If you put k equal to 5, you get 5x minus 12 equals 15. And then 5x equals 15 plus 12, which is going to be 27. So 5x equals 27. X is not an integer, right? It's 27 over 5. So you have a problem there. So this thing here is not a solution, right? So now you kind of understand the problem. Which values of k gives you an integer solution for x? Right? So just understanding the problem was the issue here. So let's go to this. Look at this problem. Kx minus 12 equals 3k. You got k appearing on both sides. So let's bring the k's to one side. Kx minus 3k. If you bring it to one side and take the 12 to the other side. So this equation implies, I'm using this symbol, if this, then that. So this thing here is if then. If this, then that. And now if you sit back and look at what you've got, k, they told you, is a positive integer. X is an integer. So what you've got here is a product of two integers, one of which is positive. And the product of two integers, one of which is positive, is 12. So it means that each of these is a factor. And k, the thing that we are looking for, is a positive factor of 12. Once you get to that argument, just this, remembering that this is an equation involving integers. So you got an integer times an integer equals 12, that becomes factorization, right? Because you're factorizing 12 into a product of integers. So you've got the final thing is k is going to be a factor of 12 and k is a positive factor. It says right in the beginning that k is a positive factor. So you write on all the positive factors of 12, that's no problem. And they want to know how many are there. So it's asking how many positive factors does 12 have, and you can see there are 6 such solutions. Sorry, I took the screen out too quickly. Look at that and are you happy with that? All right. So Shwar, no questions? Are you all okay?
No questions, Prof. I think everyone's good.
Yeah. Okay. But I want you to note that when you got integers, there's a very special way of solving it, right? And usually, it's very interesting actually when you got a problem involving integers, because then you use logic, and you have factorization, you see, and you have HCF and you have LCM with integers. So you can do all those things with integers. You can't do that with real numbers. If you have square root of 2 or half or something like that. We're moving on to problem 14. Problem 14 is another strange kind of problem. It says A, B, and C are positive integers. And now you got an equation here with 3 unknowns. And they ask you to work out A plus B plus C. So when you think about this, you want A, B, and C to be positive integers. Think about it. You say, well, 30 over 13, I can write it as 13 goes into 30 2 times. So this is 2 and 4, 26. So the remainder is 4. So it's 2 and 4 over 13, which is 2 plus 4 over 13. So you can, straight away you can say that this is 2 here, plus this part here will be 4 over 13. Right? Now, you got 4 over 13 here, and you're going to write 4 over 13 as 1 over something. So it's 1 over, and this part here, 4 over 13, when you write it as 1 over something, you're going to get 4 over 13. It'll be 1 over, it'll be 13 over 4, right? You invert. So now we're getting there. Now this part here, again, if you look at your question, you see 13 over 4 will have to be written as B plus 1 over C. So I'm going to divide 13 over 4. 4 goes into 13 3 times. So this will be 3 plus 3 and a quarter. 13 over 4 is 3 and a quarter. So this is 3 plus 1 over 4. That's 3 and a quarter. Okay. So although it looks so difficult, this problem, you've got 3 unknowns and so on. But if you use your common sense and you say, well, I'm going to divide 30 by 4, that goes into it exactly 2 times. So therefore A must be 2. And you reason it out like that. And likewise, when you come to 4 over 13, you want to write it as 1 over something. This is the way to write this. And here, you want to write this part as A plus something, where A is an integer. So you divide and you get A is 3, and the remaining part is 1 over 4. And there's your A, there's your B, there's your C. The problem was to find A plus B plus C, and it's 2 plus 3 plus 4, which is 9. So although this is a good example of a so-called non-routine problem, because you hardly would ever see a problem like this. And yet, we can just by common sense, we can decide how to solve the problem. But actually, it's just not, a random kind of a problem. The strategy is used. It used to be used quite a lot in ancient times. What we call continued fractions. Sometime you will come across the expression continued fractions. You must remember that what they do is they take a fraction like 30 over 13 and write it like this in this complicated way. And when you do it like that, then a lot of information comes out regarding that original fraction. Okay, and so that's a whole section on its own, a whole